In this tutorial, you'll learn how to control signals in WinMOD using the Y200 interface inside the iiQWorks.Sim connectivity add-on. We're working again with our KUKA KR10 R1102 robot and 4 colored blocks. In the configuration file config.dat, we've declared an integer signal called colorNum. This signal is mapped to 16 different inputs, ranging from input 120 to input 135. Now, let's look at how this signal is used in the main routine. Inside the loop, we wait for a rising edge on input 119. Once that happens, we check the value of the colorNum signal. Based on its value, the robot executes a specific case. If colorNum equals 10, the robot moves to the blue block, picks it up, waits for 2 seconds, and places it down again. During this action, output 103 is set. If the value is 20, the robot performs the same sequence with the yellow block, and output 104 is activated. If the value is 30, the robot handles the red block and briefly sets output 105. If the value is anything else, the robot moves to the green block and sets output 106. This is the default case. Now let's look at how to set up the connection between WinMOD and iiQWorks.Sim using the Y200 interface. To begin, go to the Connectivity tab in iiQWorks.Sim. First, activate the Connectivity add-on in iiQWorks.Sim. To do this, go to the top menu and click on File, then Options, and open the add-on section. On the right side, enable the Connectivity add-on using the slider. Once activated, you'll see a new tab called Connectivity. In this tab, we'll use the Y200 interface to establish the connection. Right-click and select Add Server. The setup for Y200 is a bit more advanced, because Y200 uses shared memory communication. This means a specific memory area is reserved, and data is written into and read from that area. For a Y200 interface, you need both a client and a server. In our case, iiQWorks.Sim acts as the client, and WinMOD acts as the server. On the server side, we've already defined the memory. Let's take a look at the structure with this scheme. We've created a shared memory block named Y200 for Sim with a total size of 1 kilobyte. This block is split into 2 sections. The first section is where WinMOD writes data and iiQWorks reads it. This includes inputs like digital signals, starting in the first section with byte 0 and bit 0 for input 119, then byte 0 and bit 1 for input 120, and so on. The second section starts at byte 500. Here, iiQWorks.Sim writes data and WinMOD reads it. This includes outputs and axis values. For example, output 101 starts at section 2, byte 0, bit 0. Outputs 102 to 106 follow in sequence. Outputs 101 and 102 are used for gripper control, while outputs 103 to 106 are set by the robot program. Robot axis values are stored as 32-bit real numbers. Axis 1 starts at byte 4, using bytes 4 to 7. Axis 2 starts at byte 8, Axis 3 at byte 12, and Axis 4 at byte 16. This memory layout must now be mirrored on the iiQWorks.Sim side to ensure proper communication between the virtual robot and WinMOD. Now let's open iiQWorks.Sim and configure the Y200 connection. Start by going to the Connectivity tab and selecting Edit Connection. Choose the connection named Y200 for Sim. This matches the shared memory block we defined earlier. Next, we need to set the correct offset. Remember, we said that iiQWorks.Sim starts writing data from byte 500. Everything before byte 500 is read-only for iiQWorks.Sim. Once the offset is set, click Test Connection. If everything is configured correctly, you'll see Connection Accepted. Then click Apply in the bottom right corner. Now activate the connection in the Connectivity Configuration panel. Wait until the status light turns green. With the connection active, we can start mapping data from the server to the simulation. This includes robot inputs like digital signals. Right-click on Server to Simulation and select Add Variables. We'll begin with the robot inputs. Start by adding input 119, which is used to trigger actions in the robot program. You'll see a folder structure with Boolean, integer, and floating variables. For now, we only need the Boolean variables. Since the variable names don't match our signal naming convention, we'll need to map them one by one manually. This step is important to ensure clarity and consistency in your simulation. Here's something to keep in mind. Unlike other interfaces in the Connectivity add-on, the Y200 connection must be deactivated before you can edit the signal mapping. If the connection is already active, it will automatically deactivate when you click OK after adding variables. you'll see a message confirming that the connection was deactivated. This behavior is specific to the Y200 interface. Once the mapping is complete, we should end up with a total of 17 bits, which corresponds to a memory usage of a little more than 2 bytes. Now that we've finished configuring the server to simulation side, let's move on to the second part, the memory area where iiQWorks.Sim writes data and WinMOD reads it. This includes outputs and access values from the robot. We start with the robot outputs. This section of the memory begins at byte 0, bit 0 of the second half of the shared memory block. That's where iiQWorks.Sim starts writing. We match each output signal manually. Begin with out 101, then out 102, and continue through out 106. These outputs control the gripper and signal actions triggered by the robot program. Once the outputs are mapped, we move on to the access values. These are the robot's degrees of freedom, and they're stored as 32-bit floating point values. To access them, go to the Behaviors tab and locate the access signals. Make sure to disable the box signal maps and enable degrees of freedom. Now we assign each access to its corresponding memory location. Access 1 starts at byte 4 and uses bytes 4 to 7. Access 2 starts at byte 8, Access 3 at byte 12, and Access 4 at byte 16. Each access uses 4 bytes, so we move in steps of 4, 0, 4, 8, 12, 16. This ensures that each access value is stored correctly as a 32-bit float. Once all outputs and access values are mapped, the memory layout is complete and ready for simulation. Once the signal mapping is complete, it's important to reactivate the Y200 connection in iiQWorks.Sim. This ensures that the simulation can communicate properly with WinMOD. Now you can split your screen and open WinMOD alongside iiQWorks.Sim. Start the simulation in WinMOD and press play in iiQWorks.Sim. Let's test the setup using the color num signal. First, set color num to 10. Trigger a rising edge on input 119. This should trigger the robot to move to the blue block. You'll see the robot position update, the output signal is set, and the access values are displayed correctly. Next, set color num to 20. Trigger a rising edge on input 119. The robot moves to the yellow block, output 104 is activated, and the access values update again. Repeat the process with color num set to 30. The robot moves to the red block. Output 105 is set, and the access values reflect the new position. Finally, test with a value like 31. This triggers the default case, and the robot moves to the green block. Output 106 is activated, and the access values update accordingly. This confirms that the signal flow between iiQWorks.Sim and the Y200 interface in WinMOD is working correctly, and the robot behavior matches the expected logic. You've now seen how to set up shared memory communication between iiQWorks.Sim and WinMOD using the Y200 interface, map signals and access values, and validate robot behavior through simulation. By carefully splitting the memory into read and write zones and assigning bits and bytes for Boolean, integer, and floating point values, you've created a reliable and flexible simulation environment for virtual commissioning.
Thank you for joining us today. If you enjoyed this video, please like and subscribe the KUKA channel for more content. For practical training and workshops, visit the KUKA College. Stay tuned for more tutorials and insights.
Making automation easier.